So I'm going to be looking at something known as binary shift. So this is a continuation with our work on binary. So far in binary, we have looked at how to convert numbers to and from binary. We've looked at how to store characters in binary using character encoding, and also we've learned how to store images. Now, although binary shift is not to do with how we store data in binary, it is to do with how we manipulate binary. It's kind of part of a series of lessons which we start to look at A-level, known as bitwise manipulation. Anyway, have a look at the image on the screen right now. Can you see what's happened to the top series of binary numbers to get them to the bottom? Now, hopefully, you should notice that they've all kind of shifted over by 1 to the left. So let's actually have a look at that in a bit more detail. So as you can see, this one here has gone to there, that 0 has gone to there, that 1's gone to there, and so on and so forth. Okay, so every single one of these bits up until this point has shifted over. Now, one last thing is that this bit here would have probably gone to here, okay, if it shifted over. However, because we only have 8 bits, it's kind of like disappeared, poof, in a cloud of smoke. You probably would think, actually, well, maybe it's just kind of looped over, so it's gone from there to there, which is not the case, okay? And I'll come on to that bit later, but essentially, it's all shifted over. The bit that was on the end has kind of gone, and I've just added an extra 0 to make sure I've always got 8 bits, okay? So let's go into bit shift in detail. And just for the record, this is known as a left bit shift by 1. Okay, so let's go into this. So we're going to look at how to do bit shifting and also look at how we can use it to multiply and divide numbers, which is kind of one of the reasons we actually do it in the first place. So now, binary, remember, is how we represent numbers inside the computer, so integer numbers specifically. Okay, so it's how I store the numbers 50 or 205, and so on and so forth. It works around the base powers of 2, okay, and it's a base 2. So every single digit in binary is going to be made up of 1 and 0. So, for example, let's say I wanted to store the value, I don't know, 28. Well, to store 28, what I need to do is actually work out, okay, well, which of these numbers on the top do I need, okay? Most of these numbers start at 1, start on the right, and they double each time. So starts here with 1, then 2, then 4, and so on and so forth. So every time we go one step over, we've doubled. So how do we store 28 then? Well, first of all, I don't need a 128, that's too big. I don't need a 64, that's too big. I don't need a 32, that's too big. Notice I'm starting on the left-hand side, okay? The reason I'm starting on the left-hand side is because I want to try and get the biggest binary numbers I'll fit in first. I then work out the smaller ones, okay? Now, 16 I do need, okay? So 16 works. So what I do now is basically I subtract 16 from 28. Well, let's do that calculation. 8 minus 6 is going to be 2, and 1 minus 2 is 1. So that's going to leave me with value of 12. So now I've got 12 to kind of fit in. Well, 8 fits nicely into 12. Let's subtract 8 from 12. That leaves me with 4. Well, now that perfectly fits in with 4, doesn't it? Subtract 4 from 4, that gives me 0. Well, that means I don't need a 2, I don't need a 1. Let's count that back up. So 16 plus 4 is 20, plus 8 is 28. So that there, 0, 0, 0, 1, 1, 1, 0, 0, is the binary for 28. And if you remember, that's how we convert it, okay? If you're not sure how to convert binary, there's absolutely 1,000,001 tutorials out there. Just watch one of those. Ask me for help if you need to, or if need be, just go to your textbook and just look through that. It is dead easy stuff that we've done in Key Stage 3, so hopefully that won't have been an issue for you. Let's move on. Here's some binary questions to have a go at. This is actually good practice, so converting to and from binary. Have a go at this, so maybe pause the video, keep this on the screen while you're doing it, try these questions out and see what answers you get. Okay, so I'm going to just pause for a second so you can pause. Now I'm going to go through. Okay, so here's some of the answers. I'm not going to give you all of them. So how to convert that value into denary? Well, I simply just write it out using the 8 bits. Okay, so this kind of little table I've got on the screen is very useful. You don't have to write it out as a table, but if you're struggling with binary, it really, really does help. So the first one is in the 32 position, then 16, 8, and a 1. So I add all those together and I get 57. So what's the value of 96? Again, I go for that process, start with the biggest value first. So 128 is too big, 64 is perfect. Well, 96 minus 64 is 32, so I need a 32. And because now that I've subtracted 32 from it, I don't need anything else, therefore I can just put zeros in the rest of it. Next answer is 107, so I'm just going to go over the answers now. Hopefully you've got the idea. If you don't, go back and practice, or if need be, watch the tutorials again and have another. Okay, and here's the answers to the final questions. Please do check your answers. Again, this is just good practice. In the GCSE, you guarantee to get some binary questions. It pretty much comes every year. I don't know a year that hasn't come up. The same goes for A-level as well. They love their binary because it's easy questions to write, and students tend to get them right, in all honesty. Once you've got your hang of binary, it's very straightforward. The only gotcha I've got with this one, actually thinking about it, is because people find it so easy, they don't check their answers, and I've seen quite a few really, really, really clever students get binary questions wrong, not because they don't know how to do binary, it's because they made a tiny little arithmetic mistake and didn't check their answer and just lost the marks, and they always kick themselves when they do it. So, let's get into bit shifts. So bit shifts is where we move the bits left to right. Now, when I say bit, I mean one of those ones and zeros. So the term bit represents a single digit in a binary value, a binary number. Okay, so if I'm shifting, I'm going to be moving the bits to the left, or I'm going to move them to the right, depending on the number. So we represent a bit shift when we want to actually do it using these symbols here. So I'm just circling what the symbols look like. So they're kind of two lots of chevrons, or if you want to think of it a different way, 2 less thans or 2 greater thans. So if it's pointing to the left, now my video is reversed, so that's my left and it's pointing to the right, so that's going to be left. So your left, I'm not going to do that again, that's just silly. Anyway, if it's going to the left, we're going to shift all the bits to the left. If it's pointing to the right, you get the idea. So this first one here, we've got 0, 0, 0, 1, 0, 0. And we're bit shifting that to the right, because it's pointing towards the right, by 2. That means every bit is going to move twice. So this 0 is going to move twice this way. Well, moving 0 is not too interesting. Let's move this 1. This 1 is going to go 1, 2 steps over. You can see it's now ended up in there. These zeros here effectively are destroyed, okay? So the first 2 bits on the right will get destroyed, and we add on 2 extra zeros at the end. Now it does look like that's circled around, but that's not the case. And again, I'm going to make that clear every single time. Let's look at this next one. Well, it's a bit shift to the left this time, and we're going to shift every single bit by 1. So each of these are going to shift 1 that way, that's going to go to there, that's going to go to there, and so on and so forth. And that leaves me with 1, 0, 0, 1, 1, 0. So again, this end bit here is shifting to the left, so it's going to get destroyed. And then we add an extra 0 on the other end. Again, it's not circular, it's deleting the one on the left, adding one on the right when it's a left shift, and vice versa for a right. So it's not circular. Let's have a look at what that means. So here, I've got another example. I've got 0, 1, 1, 1, 1, and 4 zeros. And this has been bit shift to the left by 2. So remember what I said, the whichever way you're going, whatever's on that side gets destroyed. Okay, so the 2 bits on the left hand side here, because it's a left shift, are going to be destroyed. And I'm going to add 2 extra zeros on the end here. So you can see here, I start off with 1100, which is essentially these 4 bits here. The next 2 bits here are the last 2 bits of the number that have been bit shift. And because I've bit shift twice to the left, I add 2 extra zeros on the right. Okay, that feels a little bit confusing, but there is a rule of thumb. When you shift, you delete that number on the side of the shift, and you add that number zeros on the other end. That's it. Okay. So let's look at this answer. So again, we got a right shift by 2. So what do? Well, we're going to get rid of the 2 bits on the right hand side. That's going to leave me 1 0. And I'll add 2 zeros on the other end. 0 0. So when it's a right shift, I delete from the right and I add to the left. Okay, so that leaves me with 0 0 0 1. Okay, and there's the answer. Let's see the next question. Okay, so I'm bit shifting to the left by 2. So again, I delete the 2 on the right. I'm going to write it out again, 1 0. And because I've bit shift by 2, I'm going to add 2 zeros onto the left. Okay, so I delete from the right, I add to the left when it's a right shift. So the answer is 0 0 0. There you go. So we always pad with zeros. Okay, so we always add zeros onto the left hand side. We always remove the bits on the right, and that's how you get to the answer. Okay. So before we get into this, it's a good time to pause. I have put in a bunch of questions for you to practice your bit shifting. There is a Python program and a website which you can try this out on. Please do that, okay? Get used to it before moving on to the second part of the lesson, okay? So I suggest pause, have a go at those bit shifts first, and then come back to this. Brilliant. For those of you not in my class and doing this on OneNote, I will include the link to that web page for you to practice in the description of this YouTube video. Okay, dokie. So, bit shift. Binary numbers can be shifted to multiply or divide, and this is one of the uses of them. It's not the only use of it, but it's the one that we study at GCSE. So I'm not going to confuse you with any others. So, first of all, we're going to look at how binary numbers can be shifted. Later, we're going to look at how this shift can be used to multiply and divide numbers. Okay. Here is some questions to have a go at. Okay, so you've already done a bit of practice, so this should be child's play. So again, I'm going to pause the video, have a quick go of these, just to make sure you know how to do it. If you don't know how to do it, the next stage won't make too much sense. So it's good to pause again, try again, and then let's move on. Okay, answers are here. So remember, these aren't circular. So when I bit shift to the left, I remove from the left hand side, I add to the right. So I add to the right, which gives me that answer there. If I bit shift the right, I'm going to get rid from the right and add a 0 on the left, okay, which gives me that. I bit shift by 3, well, guess what I'm going to do? I'm going to delete 3 from the right. I'm going to add 3 zeros on the left. I bit shift by 4, or shock horror. I'm going to get rid of 4 on the left and add 4 zeros on the right. Okay, terrible, terrible writing, I'm aware of that. Okay, and that's where all those answers have come from. So whichever direction it's pointing to, you delete from that side, add zeros on the other side, depending what the number is. So it's pointing to the left with a number 5, we delete the 5 on the left and add 5 to the right, 5 zeros to the right, okay? Hopefully that's now got into your heads. So I've already mentioned this already. You'll be able to link, I've made a link to this on the OneNote and the YouTube description to practice. Again, if you're not sure, keep practicing until you get it. So, uses of bit shift. Now, I know we've done bit shift quite a lot now, and you probably think, well, this is really easy, Mr. Hamlet, now I've got it. Most people do find this fairly straightforward, which is great, brilliant. So let's have a look at this. what is this value? Now, before we get into it, let's actually look at this binary number. Okay, hopefully you've already worked out this is 2. Yeah, so you've got 1, then a 2, so there's a 1 there, and a 2 there. I'm not going to bother with the other ones because they're all zeros, so the answer is 2. Let's bit shift it by 1. So I'm going to delete 1 on that side, add an extra 0 on this side, which leaves me with 0, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 0, 0. Okay, well, what is that in denary? Well, it's 4, isn't it? Now notice there's a little pattern there. I'm sure you've already worked out what that one is. Let's see this one. Well, this number here, okay, I'm not going to go through the whole rigmarole this time, is 9. If I bit shift this time, okay, I'm going to be left with 1, 2, 3 zeros at the front. So I'm going to get rid of that one. That's terrible Grex. Get rid of that one. Scribble, scribble. And then I'm going to write the number out again. 1, 0, 0, 1. And add my 0 at the end. So what is this number? It's 18. Okay, because we've got 16 plus the 2. Notice there's the same pattern there. What's happened? Well, I've times that by 2, haven't I? So as it turns out, oops, doing a bit shift to the left by 1 always doubles your number. So if I want to double a number really, really quickly, I just shift the bits one. And you think, well, why would I want to do that? Well, the reason why is because in the electronics, it's so much faster to quickly bit shift, move the bits over by 1 than it is to actually perform the actual multiplication itself. But it's just a quick way of doing it. If I do it to the right, okay, it's going to divide by 2. Okay, so it's reversible. Bit shift left to the by 1, it doubles the number. Bit shift to the right, it divides it. Okay, so to multiply numbers, the bits are shifted to the left. To divide numbers, we shift them to the right. Okay, and there's a great BBC website to have a go at. And again, I'll link this in the descriptions and in my OneNote if you have to have a look at it. So let's have a look at these ones. So if you bit shift by 2, it's the same as multiplying by 4. Okay, so let's see that in action. So that first binary value, I'm sure you already realise this, is 57. And if I times 57 by 4, I get 228. Okay, so this binary value is 228. So what's happened is we've bit shifted it twice that way, and same as times it by 4. If we bit shift to the right and by 1, we get 150. Well, half of 150 is obviously 75. And that's the binary for 75. So it's the same as dividing by 2. Now, just to kind of give you an indication of why that's the case, well, let's remember our binary values in the first place. So if you've got 1, we've got 2, we've got 4, we've got 8, and we've got 16. Now imagine I've just got a single bit, and that single bit is in the 2. Now, if I bit shift it once to the left, it's going to be here, isn't it? And it's no longer going to be there. So as a result of that, that number's gone from 2 to 4. It's times by 2. Okay, we've got the idea there. Let's have a look at a different one. Imagine the 1 is here, and this time I'm bit shifting it twice. So it's going from the 2 all the way to the 8. It's going from there to there. Well, it starts off 2. 2 times 4 is 8. Well, why is that the case? Well, notice that it's kind of following the same pattern as it, 2 and the 4. So watch what happens when we bit shift by 3. I'm just going to get rid of these. Let's see what happens when it bit shifts by 3. Okay, so I'm going to put it here, and it's going to go 1, 2, 3 to here. So it's going to turn in here. So this time I've times it by 2, by 4, by 8. So 2 times 8 is 16. Okay, So it's following, if I've got a bit shift of 1, it's the same as times it by 2. If a bit shift of 2, it's the same as times it by 4. If I've got a bit shift of 3, it's the same as times it by 8. If I've got a bit shift of 4, same as times it by 16. Okay, and hopefully you get the idea. It just keeps going on like that. So, and the same goes for divide. Okay, if I divide by, sorry, if I bit shift to the right by 1, I divide by 2. If I do a bit shift by 2, the same as divided by 4, and just doubles each time. So this is a good opportunity to make some notes and actually go through the tasks that I have placed into the OneNote. And those of you not watching it and using it on the OneNote, just have a go at trying out some questions. I will include some of those questions in the description for you to try out should you wish to.